Hello, everyone. My name is Matthew Glennon. I'm a freelance math tutor, and today is the first video in an introductory series that I'm running about factoring, simplification, and the distributive property. I chose this group of topics mostly because factoring is a large skill that we start learning all the way in around third to fourth grade, but we continue to grow and use all the way through high school or even college. That and simplification and knowing how to pick apart expressions into factors or smaller bits so that we can manipulate it is a skill a lot of students don't readily get in school, and something that's really important when we start working with word problems or more complicated math that feeds on these more foundational skills. That said, today's video is going to be on factoring. So how we can define a factor and also how we can find all the factors within a given number. As I said, we normally start working with this in third to fourth grade, but this can serve as a good tool to really build up those skills. That said, a little background on me. This is an introductory series to me as a tutor. I've been tutoring both at the private level and in freelance for around 5 years. And as I'm expanding my business out a little bit more, I felt a set of videos to show off me as both an instructor, my teaching style, and me as a person would be something that would be really helpful. So that said, if you like this video or if you like my teaching style, please feel free to reach out to me. I should be available on a lot of different platforms. And we could talk about you or your child's needs and perhaps go from there. All right. Thank you guys so much. Let's get right into the video. All right, everyone. So we're going to get started with just the definition of a factor and how we can factor single numbers. Now, the definition for a factor, at least the textbook definition, is that for any given value in math, every whole number which can evenly divide that value is called one of its factors. Now, there's a little bit of math jargon here, so let's break it down a little bit. When it says whole number, we're referring to numbers that don't have a decimal attached to it. So it could be 1, it could be 5. If you're higher up in grades, it could even be a negative number. Um, but it won't have a decimal attached to it, which is the important part. And it also says evenly divide. And what that means is it can divide and leave no remainder. So you won't have like 3.5 as a result. You'll just have like 3. Um, so what this is really meaning is a factor is all the numbers that are whole numbers, so no decimals that you can divide a number by and not have a remainder. And I think it's best to look at an example to sort of piece apart what that means and see it in action. So let's look at the number 10. Now, one of the first divisibility rules that we learn is that any number which is even, which means that it ends with a 0, a 2, a 4, a 6, or an 8, um, it can be divided by 2. And in this case, 10 is even, so we can say that 10 divided by 2 should give us a whole number. In this case, it'll give us 5. Now, if we connect it to our definition, 2 evenly divides 10. It gives us 5, no remainder. And it's a whole number, which means that 2 is a factor of 10. Now, one really cool thing about division is that once you know that this is true, you could rearrange it and sort of flip-flop these two guys here. So we would know that 10 divided by 2, or divided by 5, is going to be equal to 2. As such, 5 is also going to be a factor of 10. Now, when I was growing up, division was a lot harder for me to grasp than multiplication. And luckily for us, even though factors work with division and they're a division-based term, we can think about it through the lens of multiplication, which is to say, if two whole numbers multiply together to give you some number or some value, then those two numbers that you multiplied are both factors of their product, the result that you get. As such, since we know that 2 times 5 is 10, that could also be used to say that 2 and 5 are factors of 10. And in fact, this is how we're actually going to set up when we list all the factors of a number. So this is the preferred method, which I am much happier about, even though it's a division-based thing. It's a lot easier to work with. And how we would set up that list would be like this. we use something, it looks kind of like a T tree, kind of like a true or false list, but it's not. We set this T and we put the number that we're factoring up on top. And what we do is we write out the pairs of numbers which multiply together to give you your result. So in this case, we know that 2 multiplied by 5 is equal to 10. So we would write out the factors sort of like this. Also, there's one other set of factors for 10, which is almost so simple that we forget about it, but it is a really important pair. In fact, it's so important, it's called the identity pair, or I suppose an identity for multiplication, which is any number times 1 is just going to be itself. So we can also write 1 times 10 is 10. And now that we've covered this, let's look at 2 more examples and try to use this process. I'll walk through some of the divisibility rules that we'll be using, and we'll find all the factors for a group of numbers. So these 2 numbers are going to be 18 and 21. If we look down here, I already have the first set of factors for 21 written out, which is the identity pair. Now, with that said, I always make sure to write this one first because it's the easiest one to forget, but it can be really important in a lot of questions. Now, with that said, let's work up. First, let's see if either of these are divisible by 2. We know 18's even, so it has to be. And if we did the math, we would know that 2 multiplied by 9 gives us 18. Now over here, 21 is an odd number, which means 2 is not one of its factors. And one of the really cool things about factors is that if one number is not a factor of some given value, then all of its multiples cannot be factors of that value either. And what that means is, since 2 is not a factor of 21, we can say 4 is not a factor of 21, or 6, or 8, any even number, which might not help us find the factors, but it makes finding them a lot faster because we know what to cross off. Now, moving on, we're going to look and see if 3 works. Now, there is a divisibility rule for 3, which more or less says if you add up the digits of a number, so in this case, the digits would be 1 plus 8, if you get a multiple of 3, then that means this number is divisible by 3. And since 9 here, 1 plus 8 equals 9, 9 is a multiple of 3, which means we know 18 is divisible by 3, and that 3 is a factor of 18 as a result. And we would know that 3 times 6 gives us 18. Now, if we did the same thing over here, we have 2 and 1 for 21. And 2 plus 1 is 3. 3 is, of course, a multiple of itself. So we could say 3 has to be a factor. And this, at first, can be tricky to get down pat with this divisibility rule. But the good news is it's a skill that we can build up. And the way that you can build it up is just by writing any number. It could be 10 digits long and trying to see if you can do this process. It's actually kind of fun to do. And anyways, I'm getting a little off track, but we also can find that 3 times 7 is equal to 21. Now, notice how on this side, the numbers are getting larger as we get down. On this side, they're getting smaller. Well, the good news is when we keep counting up, if we find a repeat, which we will very soon, that means we have finished finding all the factors. Now, over here, 2 is not a factor of 21, so 4 we can just skip over on this side. On this side, 2 is a factor of 18, so we can check it real quick. And we know 4, 8, 12, 16, 20. It skips over 18. So 4 is not a factor of 18. Similarly, 5, the divisibility rule for 5 is also really, really easy. And it's kind of similar to evens and odds. If a number ends with a 5 or a 0, it's divisible by 5. And since neither of these numbers are, that means neither of them have 5 as a factor. And then last but not least, when we get to 6, we're going to see that it is divisible by 6. You would get 3. But you see how it's the same pair as this one, except flipped around? That means that we can erase it as it's kind of a duplicate. It's right, but it's a duplicate, so we only want to write it once. Now, with that said, over here, since 2 is not a multiple of 21, or since 21 is not a multiple of 2, we know that 6 cannot be a factor of 21. I think I had a little bit of a hiccup there. Let me try one last time. Since 2 is not a factor of 21, 6 cannot be a factor of 21, since 6 is a multiple of 2. There we go. And then we would get 7 and 3 again, which means it starts repeating. Which means if we asked what the factors of these numbers are, we would say the factors of 18 are 1, 2, 3, 6, 9, and 18. And over here, the factors of 21 would just be 1, 3, 7, and 21. There we go. Now, there is a special case here, or a lot of special cases. And to highlight that, let's look at 5. So if we looked at the factors of 5, we would start with the identity, 1 and 5. And let's start moving up the list. So 5's odd, so it's not divisible by 2. It would go 3 and then 6, so it's not divisible by 3. Then it would go 4 and 8, so it's not divisible by 4. Which means 5's only factors are 1 and itself. And this is actually a pretty special case in math, as there's a lot of numbers which only have 1 in itself as its factors. And we have a very special name for this. We call them prime numbers. And they're very special numbers just because if you're trying to simplify something or find a factor that's in 2 different numbers, and one of them's a prime number, that means you only need to check one number, and if it's not there, then they don't share any factors, which is really convenient. Now, with that said, we have just finished up with the definition of a factor, so let's move on with simplifying fractions, which uses factoring in an implicit way to sort of make an expression or a fraction easier to comprehend or use.